is Nicolette Bert, and my project is the effect of water temperature on the heart rate of Daphnia. Daphnia are small planktonic crustaceans that eat algae out of water and typically have fast heart rates. They usually live in fresh water and can be found in lakes, small pools, and streams. They are prey for fish and other invertebrates. Because of this, they tend to go deeper into the water during the day and come closer to the surface at night. Daphnia are filter feeders, which means that they filter their food out of the water. When the temperature of water increases, the metabolic rate of Daphnia usually also increases, creating a demand for more oxygen and energy for the Daphnia. However, when water temperature increases, oxygen content in the water can decrease. Therefore, the Daphnia may not get all the oxygen they need, creating an imbalance between the oxygen that the Daphnia require and the oxygen they actually receive. The purpose of this project is to find out which temperatures of water will cause Daphnia to have the highest heart rates. This is important because Daphnia can help keep water clean by filtering algae and bacteria out of it by eating it. If Daphnia are more active, they will have a higher heart rate, and they are often more active due to higher water temperatures. When their heart rate increases, they will often eat more and therefore filter water more. Daphnia have an open blood circulation system. This means that their blood is not confined only to their heart and blood vessels, but can flow all throughout their bodies. Daphnia also have hemoglobin in their blood to support oxygen transportation. The concentration of this hemoglobin can vary as water temperature and oxygen concentration in the water around the Daphnia vary. As water temperature increases, the metabolism of Daphnia also increases. As the Daphnia metabolism increases, they become more active. Therefore, their respiration rate and heart rate should increase. Therefore, my hypothesis is that as water temperature increases, the heart rate of Daphnia will also increase. First, a Daphnia was taken from room temperature water, which is at 20 degrees Celsius, and placed under a microscope. It was then videoed, and the video was then slowed down in order to count the beats per minute to find the heart rate of the Daphnia. This was repeated with 15 Daphnia. Next, 15 Daphnia were put into a refrigerator, which was at 4 degrees Celsius, and left for 20 minutes. Their heart rates were then measured in the same way. Lastly, 15 Daphnia were put into hot water at 40 degrees Celsius and left there for 10 minutes. Their heart rates were then also measured. The average heart rate for the Daphnia in room temperature water was 141.7 beats per minute. The average for the Daphnia in the hot environment was 135 beats per minute, and for the cold environment was 153 beats per minute. However, a high standard deviation appeared in all of the environments. This graph shows the average heart rates of Daphnia in each environment, and for the hot and cold environment shows the average heart rate of the Daphnia that survived, and as well as all of the Daphnia, since a few of the Daphnia died in each environment due to the extreme temperature. Although the average temperature was highest for Daphnia in the cold environment and lowest for the Daphnia in the hot, a t-test did not show any statistical significance between room temperature and hot or cold environment. However, a slightly significant difference was seen between the cold and the hot environment. This showed that a big temperature change, such as a big raise in temperature, created a small change in the heart rate of the Daphnia. In this case, a raise in temperature created a small lowering of the Daphnia's heart rate. Since the results seen were that hotter temperatures slightly lowered the Daphnia's heart rate, and my hypothesis was that hotter temperatures would raise the heart rate of Daphnia, My hypothesis was therefore rejected, since the opposite result was seen in the experiment. This may be due to that as temperature increases, oxygen content of the water can also decrease, creating an imbalance in the Daphnia and therefore lowering their heart rates. A different result may have been seen by using less extreme temperatures and leaving the Daphnia in the hot or cold environment for a longer period of time. This would eliminate the Daphnia that died, having all of them survive with less extreme temperatures, therefore providing more accurate data. Allowing the Daphnia to be in the hot or cold environment for a longer amount of time would also give them more time to adjust to that environment, possibly making a more significant change and also being more accurate. This is a possibility for future continued research. Thank you.